All right, checkpoint exercises for section 1.10. With problem 1, we're asked to compare each of the rational numbers given. If we look at 7.4 and 2 times the square root of 14, and again, you can approximate these using successive approximations until you get it past the 10th place, or you can use your calculators. But 2 times the square root of 14 is approximately 7.483. So that means that 7.4 is less than 2 times the square root of 14. With 6.15 and 6 1/5, we have 6 1/5 is the same thing as 6.2. So 6.15 is less than 6 1/5. Here things get a little bit more complicated. We're looking at pi squared. If you have pi on your calculators, you can go ahead and use that value. Or you can just use 3.14. If you use the actual pi value, you're going to get an approximation of pi squared being 9.8696. And then 3 times the square root of 11 is approximately 9.9498. That's actually rounding correctly. 9.9499. It wouldn't have made a difference, but that gives us that pi squared is less than 3 times the square root of 11. Now with the last one, with number 2, we're given a set of numbers, and we're asked to order them from least to greatest. So let's go ahead and put them in a similar format. We have 449%. That's equal to 4.49. 4.494 is already in a decimal format. 4.44, we can go ahead and just for visualization see that it's 4.4444 ... And then the square root of 20, we know that that equals 2 times the square root of 5. We actually looked at the square root of 20 in one of our examples. And if you remember from that, it's approximately 4.472. So looking at it in its original format, well, let's go ahead and order them with what we have. So 4.4444 repeating, that's going to be the smallest. 4.472 is going to be the next in the list. And then 4.49 is going to be the next greatest. And then 4.494. So in their original format, we have 4.4 repeating, square root of 20, 449%, and 4.494. All right, with number 3, we're asked to name all of the sets of numbers that each of the values given belongs to in the real number system. Again, we're given that they're real numbers, so we don't have to classify them as such, but we want to classify all of the others. 3/16, that's going to be rational. It's written as a fraction. Any number that can be written as a fraction is rational. Square root of 30. Anytime we have the square root of a non-perfect square, which 30 is not a perfect square, that's going to be irrational. Square root of 121. We should recognize that that equals 11. So that's going to be, since it's positive, it's a positive integer, that's going to be natural or counting, whole, integer, and rational. And negative square root of 121, that equals negative 11. So that takes out natural and whole, but leaves us with integer and rational. Now, number 4, we're asked to evaluate the statement, rational numbers are integers. Is this always true, sometimes true, or never true? Well, integers are rational numbers. So we know it's at least sometimes true. It's not it's not, to use a double negative, but it's not never true. But is it always true? Can we think of any rational number that is not an integer? Well, yeah, there's plenty of them. Anything that doesn't have 1 in the denominator and a whole number on top, that's going to be a rational number, but not an integer. 1/2, 1/3, so on and so forth. These are all rational numbers, but they're not integers. So this statement is going to be sometimes true. Now, on a side note, had it said integers are rational numbers, that would be always true, because any integer can be written as a fraction over 1.